Well, hello everyone. Welcome to this Wind Power Engineering and Development webinar, the WindBridge Advantage, easy anemometer replacement for any turbine, anytime. I'm your host, Paul Dvorak, editor of Wind Power Engineering and Development magazine. Thank you for joining us. Now, just before we get started, I'd like to, before we introduce our speakers, let me give a little, do a little housekeeping here. The webinar will be available for reviewing at windpowerengineering.com, and a link to it in the slides will be emailed to everyone who's registered. At the end of the presentation, we'll have a brief question and answer session. Now, of course, not everyone that wanted to attend today's webinar could be here, but you can help them learn from it by tweeting the key points and the takeaways that you think important. In your tweets, be sure to include the hashtag WindWebinar. Now, after the presentations, I'll read the questions that you and the audience have submitted, and you can do that by typing them into your questions box in your GoToMeeting panel. That should be on the right of your screen. If it's not, look for a small left-pointing red arrow, and click on that, and the question box will appear. Now, I suggest not waiting until the end of the presentation. Type your questions in as they come to you, and we'll try to answer as many as possible before our time is up. Now, let me tell you about our speakers, and I'll turn the microphone over to them. First, we'll hear from Ann Pattison. For the past 6 years, she's been the Vice President of Sales and Marketing for Lufft USA. Lufft USA has been incorporated since 2010, and it's the Lufft headquarters for sales and systems integration, covering all of the Americas. Lufft in Germany has been manufacturing quality meteorological sensors and systems since 1881. Ann has been working in the wind industry for more than 10 years, since her start at Clipper Wind Power in 2004. And she has a background in weather systems for a variety of applications, including sensors for turbine components and systems. Then we'll hear from Rob Lopez. He's the Director of Business Development at NorCal Controls ES, where he is responsible for finding new business opportunities and promoting NorCal's array of engineering services and solutions. In Rob's last position as a project manager and project technical lead, he's responsible for the entire life cycle of many projects in the traditional and renewable energy sectors. As one of the founding members, Rob has obtained a breadth of knowledge in the power generation industry. He has a bachelor's degree of business with a concentration in management information systems. His past work experience includes project management, business programming, application development, and web design. And with that, let us begin. Ann, the microphone is yours.
Thank you, Paul. Hello, everyone, and thank you for joining today. We hope that you find this to be an informative presentation and a good use of time. We'll spend a little bit of time today introducing the WindBridge wind sensor replacement solution for wind turbines for all PLCs. A little bit about us, NorCal Controls, an energy and systems integration for energy solutions, and Lufft is a manufacturer of wind sensor technology and weather station technology. We've partnered on this project in order to solve a problem that we kept seeing come up again and again by many wind turbine customers. How do you quickly and easily replace a wind turbine sensor, a turbine control sensor, for any turbine, no matter the age of the machine or the type of PLC or the communication protocol of the wind turbine PLC? So what are the end goals here? What are we hoping to achieve from this project, this partnership for the WindBridge drop-in replacement solution? Well, of course, uptime and efficiency of a wind project. That's really the end goal of all solutions for wind turbines, making more energy, and then of course to lower costs for owners and maintenance managers that are managing wind power plants. So just a little bit of data, some fun facts about the wind industry today. In 2011, nearly 40 billion worth of wind installations in the US came out of warranty. Now obviously it's 2015. So there's many more today than that. This, of course, thrusts the financial risk onto the owner to provide cost-effective operation and maintenance. This spread a growth and desire for turbine longevity and reliability. That's really where the industry seems to be going now. There seems to be a lot of more companies now that specialize in maintenance contracts, and obviously lowering costs is a priority, since most PPAs for wind power plants last more than 20 years. the next 20 years, the U.S. will require more than 100,000 additional wind turbines to supply 20% of the nation's electricity. Now, I mean, you think about this for the U.S., and this is older data from AWEA. I mean, think about this globally. This data point is probably extremely low. I mean, you think about electricity demand growth today and how it's unprecedented, especially considering China or other fast-growing economies. For existing wind turbines, cost-effective replacement of turbine parts is a necessity. More energy demand required from an aging turbine fleet, and there's qualified maintenance services can cost hundreds an hour. Now, a lot of turbine plants operate that are out of warranty operate on maintenance contracts by companies. However, there are smaller projects that maybe don't have that and just have to have small, hourly maintenance contracts. This can be quite expensive. So, of course, I've said this again and again, but project owners need to find ways to reduce costs and increase reliability. The wind sensor is a part of every turbine, and the WindBridge can help to reduce costs for anemometer replacement. So just a little bit about wind turbine control anemometry, the Lufft Ventus and wind turbine control anemometry. Here you'll see just a few photos, one from China. The Ventus is there atop a Chinese wind turbine. And then here's one in the middle from Scotland. I believe that's a Polaris wind turbine, a smaller wind turbine. Also has a Lufft Ventus turbine control. And then there's a larger Gamesa turbine. I don't believe those are Lufft sensors on top, but those also, there are two redundant wind sensors on top of that turbine. So point here, every turbine above a certain size requires a wind sensor on top of the nacelle in order to efficiently operate and for safety. It helps to yaw the nacelle into place. Traditional wind sensors, and when I say that, I'm meaning a cup and vane sensor, requires regular calibration, which is a recurring cost. This can happen as much as every year or even more often depending on weather conditions of the installation. Cups can fly off, they can ice out, they can go out of calibration. Basically, my point here, there will be maintenance. Ultrasonic sensors can reduce this maintenance, but even some ultrasonics with no moving parts maybe are not designed or able to withstand certain extreme environments. This is where maybe the Ventus would come in. Sensor replacement is dangerous and expensive. You can see there in the middle the guy with the climbing gear, specialized climbing gear, climbing the side of that small turbine, and the very narrow walkway he has to work on to replace that sensor. Sometimes these can be 80, 100 meters up in the air. So certified climbers are required, and a small project may not have easy access. There's actually even cases where you may not even be able to climb a turbine. You might have to get a crane or a cherry picker to replace a sensor. This is very expensive. So it's critical to have a robust, long-lasting wind sensor like the Ventus turbine. The WindBridge provides a drop-in solution and takes away the headache of integration for this. Owners and operators need a solution for any turbine, anywhere, at any time. And that's what we have come up with today. Wind sensors must withstand the most extreme conditions. So I just have some examples here of extreme conditions: ice, dust, offshore. There's another cold weather solution there, and you can see how there's ice developing on those blades. I just want to take an opportunity here before we go into talk about the WindBridge. So the WindBridge can work for an anemometer replacement solution, but Lufft also offers an ice detection sensor that can be part of this package. I won't get into that today, but if you want to talk a little bit about that, please let's talk offline. It can be integrated into the package, and contact me. I think my contact information is at the end. But you can see here, these are very extreme environments, so where anemometer replacement might be required. And we just want it to be easy, quick, and obviously low cost. This shows how a situation where you might want to replace a wind sensor and a traditional wind sensor, a traditional cup sensor, and a lot of the older wind turbine installations that are more than likely out of warranty. There's a cup sensor here. You can see that it's iced over, probably unheated. The turbine is probably not operating because this wind sensor is frozen, or it shouldn't be. And then you can see the Ventus there, ice-free operation, and how it's a good, this is where you'd want to replace the sensor. So I'll hand the microphone now over to Rob, and he can explain a little bit more about the WindBridge and how it works. So thank you. Go ahead, Rob.
Thank you, Ann, and hello, everyone. Yeah, so the WindBridge. The WindBridge is a smart signal converter device configured and programmed to allow any existing wind sensor or anemometer to integrate seamlessly into an existing legacy PLC. When paired with the Lufft ultrasonic Ventus, an all-in-one sensor with no moving parts, the WindBridge signal converter is the perfect solution for sensor replacement. Below is a depiction of the WindBridge. It has a small footprint and can be housed in the existing PLC enclosure or in a separate heated enclosure as another option. The proposed Ventus WindBridge Package is an easy drop-in solution to replace an aging, broken, or outdated anemometer or wind vane. With the WindBridge, no modifications to the existing legacy PLC is needed. The WindBridge emulates the anemometer sensor outputs, which the PLC is programmed to read. Full integration support is provided from replacement to power up to post-operation if needed. Here are just a few manufacturers on which we can integrate the WindBridge, as well as some other PLC manufacturers in which we can integrate with. Here's an existing depiction of a customer in Minnesota who's looking to upgrade to the Ventus. They currently have an NRG 200P model wind vane and an NRG 40C model anemometer installed. Both sensors are currently wired directly to the turbine's legacy PLC, which is located at the bottom of the turbine. At the wind turbine site in Minnesota, the winters get very icy, and as you can imagine, the existing mechanical sensors aren't the most reliable, particularly the cup and vane sensors. Here is a depiction of the new proposed setup by Lufft and NorCal. So here the Ventus would replace the NRG sensors. The Ventus sensors would wire directly into the WindBridge for sensor communication to the legacy PLC. The Modbus protocol output from the Ventus is translated to the expected PLC input format that the PLC is expecting to see. Here are some base specifications for the WindBridge. One thing to take note of is the capability for the power input. The WindBridge accepts both AC and DC input formats. The WindBridge is also outdoor rated, so it can withstand the extreme temperature environments that were mentioned by Ann. For a full data sheet for the WindBridge, you can contact myself or Ann and we can provide that. And that's it. Thank you for your time, everyone. I'm now going to pass it back over to Ann, who will complete the presentation.
Thanks, Rob. So just a little bit more about the package. So as Rob mentioned, Modbus output from the Ventus is translated through the WindBridge to any PLC input format. And it's heated for extreme temperature conditions. The Ventus also is able to operate offshore. It's created of a special metal that will withstand high levels of salt in the atmosphere. It's also rated to IP68, which means it can be submerged for more than an hour and will still operate. It has built-in capabilities, obviously, of measuring wind speed and wind direction, and it has air pressure reading as well as a virtual temperature reading that's accurate up to 2 Kelvin. It also has a wind quality reading, so you can tell if there's levels of debris or ice building on the sensor. We also have a flexible power draw that is available depending on the power that your system requirements of your power. We have a 240 watt heater standard, but again, that can be flexible depending if you have a lower amperage available. Oh, and we have a mean time between failure of more than 15 years. These are just a few pictures of Ventus mounted atop wind turbines in various locations. Just kind of wanted to show how maybe sometimes it's a redundant sensor with a traditional cup sensor, or it can be mounted alone or as two Ventus on top each turbine. A little bit more before we just leave some room for questions. We just wanted to talk a little bit more about the installation in Minnesota. So again, really cold. This was the perfect opportunity for us to install the WindBridge. We had a customer that was looking to replace an aging anemometer with the Ventus. They wanted to have a maintenance-free, worry-free sensor on top of the turbine that would last a long time. So they chose the Ventus. It's a cold weather environment in Minnesota. They had power to the sensor, or they had power from the turbine to the sensor. Replacing the NRG, the WindBridge is pre-configured by NorCal, so NorCal's configured it and were able to just drop it in to the turbine. So low-cost upgrade without any PLC upgrades or analysis from the project owner. Now this was a situation where it was a small owner that had a few turbines, but obviously we could installation to any volumes, to any size of turbine and any PLC. So if you have more questions about that and any specific installation that you might have, I encourage you to we can do it during the Q&A or probably offline, and we'll be able to discuss. So that really concludes our presentation. I think we'd like to leave a lot of time for discussion and with your questions on the product itself. Rob has invited Bob Lopez, an engineer from NorCal, to answer questions as well. So we invite any questions you might have. So Paul, I'll hand it back to you.
Okay, very good. Thank you very much, Ann and Rob. I enjoyed that. Hey, let's start with, I have a question. A couple of your photos are images of the Ventus wind anemometer. Showed some with looked like a three-pronged structure around it, and others without that structure. What were the three prongs for?
That three-prong structure is a lightning rod, and that was a picture from China, and it was a special design that they used there. I know it was kind of a new look to me as well from the traditional rods that I've seen, but that's what that is.
Okay, we have some number of questions here. One is from Mr. Savia, and he asks, this is a two-product announcement, right? You've got the Ventus and the WindBridge. And you're marketing those, you're selling those as a package. Is that correct?
Yes, this is a package. I mean, obviously they are both available, but it's a package. Okay. Yeah, that's what we're presenting today. All
right, that's excellent. Okay, and then let's see here. And this is probably for you, Ann. Would the WindBridge and Ventus combination be viable for offshore wind applications? And can you speak to its survivability?
Sure. Yes, absolutely. The Ventus is available for offshore applications, and the WindBridge also, because of its ruggedized design, is available as well. So we've the Ventus has actually been tested to the most extreme sensor of anything that we have in our fleet of weather stations. We've run it through the HALT test, which is basically designed to destroy a sensor, and we survived. We've measured it down to negative 95 degrees C and up to 95 degrees C positive, and it has actually read data up to, to both of those extremes. We've submerged it for an hour, and then it still reads data. It's incredibly vibration resistant to military standards. So we really think that it's a good option for offshore application, and it will survive in these kinds of conditions.
Okay, very good. So I have to ask another novice question. If an anemometer freezes, a cup anemometer freezes, does the turbine shut down?
Yes.
It does. Okay.
The design of the PLC is that it would shut down because it's a safety issue. If wind goes above a certain level, depending on the type of turbine, but if wind goes above, I know in the larger turbines, maybe 25, 28 meters per second, it actually could have undue stress on the blades.
I see. Yeah, that makes sense. Okay. Here's a question for Rob. Do any modifications need to be made to an existing PLC? And what about the existing wiring from a PLC to the current anemometer?
Okay, yeah, so that's a great question. So the great thing about the WindBridge is that no modifications will need to be made to the existing PLC. That includes the configuration, the program, as well as the wiring. So we can utilize the existing wiring going into the PLC to the anemometer being replaced, and we can wire that directly into the WindBridge. And then the Ventus cable, the serial cable, will just be plugged in on the other side of the WindBridge. So no modifications will be required.
Okay, very good. And here's another one for you, Rob. Who will do the installation, or who can do the installation?
Yeah, so we will provide a short questionnaire to the customer, which asks information pertaining to the PLC make and model, the I/O cards being utilized, as well as for any wiring schematics that are available. And then granted that enough information is supplied, an installation manual will be provided so that the local laborers can do the installation themselves. Of course, we'll provide remote support as needed.
Okay, very good. All right, ladies and gentlemen in the audience, I want to remind you it's time to ask questions, so type them in. Well, here's another one. What types of wind turbines can the wind talker operate on? Anne?
Any. I mean, you saw the slide with just a few, but I think it's important to note that most turbines, not all, but most wind turbines above a certain size have a turbine control anemometer. And so really, and there's a lot of older turbines out there. Palm Springs are out there. I mean, those turbines, a lot of them are aging. They probably have old cup and vane anemometers. I mean, the wind industry is not young. So I think any turbine that this package can help. The Ventus with the WindBridge to replace the wind turbine or the turbine control anemometer, I think is a really good option for a lot of those older turbines where maybe it's not known what the communication is, or the PLC is maybe out of out of production. I mean, this is a really good solution for that. So any turbine, any PLC, anytime.
Okay, well, Mr. Savia asks another question here, and Neil can do interpreting here. Is there any proprietary content for the product offering?
Not on our side, Rob. That's one for you.
No, not from WindBridge side either.
Okay, all right. All right, we're almost at the end of our questions. I'll ask a couple more here. Are there any wind sensors in particular that should be replaced after a certain amount of time? Anne, want to try that one?
Well, not necessarily. I mean, I think it's just a matter of, I think that the cup and vane sensors will need to be calibrated and maintained. And I think I alluded to this earlier in the presentation, that there's anything with physical moving part. There's wear and tear on the mechanical system. So over time, you won't necessarily need to replace it, but recalibrate it in order for accuracy. Now, does this have to be done every month? No. But depending on where the turbine is installed and where the sensor is installed, there may be more or less wear and tear on the instrument. So, I think, do we recommend replacement? Yeah, I mean, it's really up to the owner, and how often do they want to have to calibrate a sensor, or maybe they're having some issues with icing. Those would be the big reasons where I would see to replace with this kind of package. And then, as far as ultrasonic sensors on turbines, say for a large project where maybe there's a large project that's managed now, it's out of warranty and maybe managed by a maintenance contractor. Maybe there's a certain wind sensor that the turbine OEM has specified, and but this allows the maintenance contractor or the owner to change that no matter what the turbine OEM has provided. There's for various reasons, they might want to change. Maybe it's delivery times, maybe it's icing issues, maybe it's just because of cost. And so this gives a different option that allows you to just freely change the anemometer if for whatever reason.
Mm-hmm. Okay, very good. And Rob, I think this is the last question. Is for you. What makes the Ventus a good fit for the wind turbine, for the wind talker integration solution?
Actually, this is Bob speaking, Paul. So I was going to take that question for Rob, if that's okay. Hey, yeah. So to answer your question, just briefly, it's the partnership we have with Lufft was born out of necessity, and these guys are innovative, and we like to think that we are too. So we think that the pairing, although any other company probably could have come up with the same solution, maybe a different flavor, is a strong one. I think our partnership is going to be very strong. People not only are going to be extremely satisfied with the Lufft anemometers because they're killer equipment, but also just the low using the WindBridge to bring that data back into their legacy PLC, it's almost going to be a no-brainer.
All right, very good. All right, well, we're out of questions. We're at the end of our allotted time, too, ladies and gentlemen. So once again, this webcast will be available for reviewing at windpowerengineering.com. And just one final message, you can follow Windpower Engineering on Facebook, Twitter, and LinkedIn. So this concludes our program. I want to thank Ann and Rob for their insightful presentations, and Bob for jumping in at the last minute, too. And I want to thank everyone in your audience for your attention and your good questions. So from the staff here at Windpower Engineering and Development, we wish you all a good and productive day.